All right, so yeah, we've covered a little bit of ground on factoring binomials, and just kind of rehash that a little bit. We know that when we're factoring binomials, that is a polynomial that has two terms. One thing we can look for is squares, right? And if we have a difference of squares, that factors nicely, doesn't it? If we have, say, a 9x squared minus 49, and I want to factor it. Well, a note there, I've got a square. 9's a square, 49's a square. Here's two squares, and the sign is subtraction between them. Yeah, that factors nicely. How does that factor the difference of squares? Well, what you do is you factor into two binomials, right? You break down the 9x squared, and the thing about it is it's real nice because it's the same basically on both sides, right? 3x and 3x for the 9x squared, then the 49, it being 7 squared. We're going to do 7 and 7, but it is a minus, so that tells me one's a minus, one's a plus. Okay, so that difference of squares factors out very nicely. Now, what about a sum of squares? Well, if it was 4x squared plus 25, yeah, that's also really nice. It's squares. But what about a sum of squares? It is prime, yeah. Sum of squares is always prime. So that's how the binomials, if they're squares, work out. Well, what I also wanted to show you today was something else we can look for on binomials, and that is cubes. Binomials that have cubes in them. Now those are probably not as familiar. We're more familiar with squares usually, but cubes, well, they work a little bit differently, but of course I'm talking there x cubed, y cubed, but I'm also talking about what are some other numbers that are cubes, like 8. 8's a cube, 27's a cube, 64 is a cube, because those are numbers that you cube another number and get, right? 8 is 2 cubed, 27 is 3 cubed, 64 is 4 cubed, right? 4 times 4 times 4 gives you 64. So those are the ones. Just to name a couple others, 5 cubed is 125. 6 cubed is 216, so on and so forth. Just keep cubing the smaller numbers there, and you get those. But mainly be dealing with these. 10 cubed is another one. Probably you'll see 10 cubed is 1,000. So yeah, if we also come across binomials, if they're not squares, that's always the first thing you look for. What about cubes? Can we have are they possibly a cube in our binomials? And if they are, turns out they do factor. And so that's what let's talk about here next. All right, let me start with 8x cubed minus 27. (8x cubed minus 27). Well, obviously, those two are on our list there. 8's a cube, 27's a cube. So here I have what? Difference of, not squares, it's a difference of cubes, isn't it? Because that's a cube, obviously, and then x cubed is a cube, and then 27 is a cube. So this is now we're not dealing with squares, but cubes. All right. Well, turns out it's a little different. to factor a difference of cubes. It's not a binomial times a binomial. For cubes, it's going to be a binomial times a trinomial. That's a little bit different than previously we've tackled. So yeah, I've got a binomial times a trinomial. And one way you can think about factoring the cubes is via a formula. So let me talk about that right here. I think I can put that right here. The difference of cubes formula. And I'm going to use a cubed and b cubed. If it's a cubed minus b cubed, then I want to factor that. Turns out it's, let me just write here, a minus b. And I'll explain what a and b are here in a minute. It's really basically a is what you cube to get the first term, and b is what you cube to get the second term. So it's a minus b is the binomial, then it's a squared plus a times b plus b squared. That's your trinomial. So whatever a is, you just plug it in for the a respectively here, and then whatever the b is, the cube root, what you cube to get b cubed there, plug that in for b. That's the way it works. So it's not as maybe nice and nifty as the squares, but that's how it works. All right, so right here, what we've got is 8x cubed minus 27. So that would mean a, what I cube in the formula, well, I would cube to get 8x cubed. Well, I would cube 2 and x, right, to get 8x cubed. So that's going to be my a. That's what goes right here. B is what you cube to get the 27. So what would I cube to get the 27? I would cube 3, and that's what goes right here. And then notice the sign is minus just like it is there. So that's the binomial. Pretty easy. Now for the the trinomial. All right, so what does a trinomial include? Well, it's a little different. It includes an a squared, a being 2x, so I'm going to square that right here. Which means I'm going to square 2 and x. Then what? Plus a times b, so it's going to be plus, the a is 2x, times the b, which is 3. And then plus b squared. B is 3, so I'm going to square that. So I'm going to write it like that this first go around anyway. I'm going to simplify it, but okay, let's see what that gives us. So that gives me 2x minus 3 times, what does this give me? 2x quantity squared. 2 squared is 4, x squared is x squared. Okay. 2x times 3 is 6x, and then 3 squared, that would be 9. There you go. 8x cubed minus 27 is, believe it or not, 2x minus 3 times 4x squared plus 6x plus 9. Okay? Now, that looks awfully long and drawn out for just a binomial, but we can check that real quick here just to show you once that it does work. If I check that, in other words, multiply this back out, take this 2x times these 3 here, that would give me what? 2x times 4x squared would be 8x cubed. 2x times 6x, that would be 12x squared. And then 2x times 9 is 18x positive. Then take the minus 3 times all 3, so that would be minus 12x squared, minus 3 times 4x squared. Minus 3 times 6x is minus 18x, and then minus 3 times 9 is minus 27. And you see why this works. What happens here? 12x squared minus 12x squared, gone. 18x minus 18x is gone. So we wind up with 8x cubed minus 27. Okay? So it works. You don't have to check it necessarily every time, but just wanted to show you that it does work. Okay? All right, so let's try try another one here. All right, this one's going to be 64y cubed minus 125z cubed. 64y cubed minus 125y cubed. Well, one thing to note there, I start off here, that one's a square. However, nothing else is a square. So it kind of fizzles out with that square. But it is, however, cubes, isn't it? 64 is not only a square, but it's also a cube. It's 4 cubed. 125 is a cube. It's 5 cubed. So this is cubes, isn't it? This is a difference, again, of cubes. So I'm going to factor it using that formula. It's the binomial times the trinomial formula there. All right, so the first thing that goes here, well, it's the cube, what you cube to get 64y cubed. Be 4y, wouldn't it? 4y. And then right here, what you cube to get 125, z cubed, so that would be 5z. And then, like I said, the minus goes right there between them. All right, now, one thing, one way you can kind of remember the rest of it, get rid of these arrows real quick here. What I'm going to do is I'm going to take this 4y and I'm going to multiply it by itself. So just kind of make a loop right there. So that's 4y times 4y, so that's 16y squared. Then on the end here, I'm going to do the same thing with the 5z. I'm going to take 5z and multiply it by again by itself, so that's 25, 16y squared, and this is 25z squared. And then the middle is this times this. 4y and 5z is 20yz, and then everything's plus between them. Just another way to remember it, but it's a squared plus AB plus B squared. Is how that works. Okay? All right. Now, come to find out, that's the difference of cubes. The sum of cubes also factors, and it's very similar to the difference of cubes. The sum of cubes formula goes like this. If you have a cubed plus b cubed, then that factors as, I'll write it down here, a plus b. That's similar, isn't it? But instead of a minus b, it's a plus b. And then over here, it's a squared minus a times b plus b squared, which is similar to the difference of cubes, except what? The minus right there in the middle. So everything's the same, except this is plus and that one's minus, instead of that one being minus and that one plus, you see. Okay? So it works just the same with that little bit of alteration. All right. So let's x cubed plus 1,000. Not squares. However, it is cubes, isn't it? that's a cube, and 1,000, well, we discussed that. That's a cube because what do you cube to get 1,000? 10 cubed gives you 1,000. So yeah, these are both our cubes. It's a sum then of cubes. And unlike the sum of squares that wouldn't factor, sum of cubes does factor. And it factors just like that. All right, so here's how it works. So I'm going to take what goes first. Cube root of x. What you cube to get x cubed? That'll be x. And then cube, what you cube to get 1,000 be 10. And then, yeah, that stays the same. There's plus. Okay? Pretty much the same. All right, then here, what we do is, yeah, we square this. Take this times itself, so that's x squared. That times that, x times 10 is 10x. And then the last is that one times that one, so that's 100. The only difference is there's a minus between them instead of a plus. Really, it's just the opposite sign of what you start with there. Okay? Questions or concern? And again, it works out. If you multiply it all out, the middle terms do drop away. So it does work out. Let me give an example of one more. 27 y cubed plus 1. 27 y cubed plus 1. Well, again, we're talking cubes, aren't we? 27 is a cube. Y cube's a cube. What about 1? Is 1 a cube? What would you cube to get 1? You would cube 1 to get 1. Yeah. 1 can be a cube. It can be a square. It can be a fourth power. Yeah, 1's a whatever of itself, a cube or a square. Yeah, so this is cubes again. This is a cube, 3 cubed. 1's a cube. All right, so how does it work? Well, first of all, I take 3y and then 1. And keep that plus right there. Then multiply these two together, so that's 9y squared. 3y times itself. Then I multiply these two for the middle term. 3y times 1 is 3y. It's a minus. And then the last term is this term by itself, plus 1.
Will there ever be a time when
Can you have a time when there's cube and squares? Yes, you can. I don't know that we will have any. But, yeah, you could get, when you get higher powers, like sixth power, if you have a sixth power, yeah, that's both a square and a cube. So, but I don't know that we'll run into those quite yet. All right. Any other question on the binomials?